Hey everyone, my name's Landucci. Today I'm going to be talking a little bit about universal frameworks for grounding LLM-based AI copilots. So what exactly is grounding? For those who don't know, grounding is a process of giving an LLM domain-specific knowledge so that it can answer queries about that domain-specific knowledge more effectively. There are multiple ways of doing this. I have one example on the slide right now. So if we, for example, had an AI copilot for Canvas, we might want to ask, when are my office hours today for a specific class? What grounding can do is go into a retriever and based off that query, retrieve the relevant documents needed that tells the LLM when are the office hours today. And based off that, the LLM can provide a more effective and accurate answer. So why exactly does grounding matter? So there exist many AI copilots around us requiring domain-specific knowledge. For example, Microsoft 365 Copilot may require business-specific knowledge. Notion AI may require specific knowledge about your notes. And without this process of grounding, these AI copilots will inevitably suffer from hallucinations and overall will not output the desired answer. So I have another graph to the right on this slide that's asking the same question, just when are office hours today? And without that domain-specific knowledge about the class, the LLM isn't going to know how to answer that question effectively. It's going to have no context as to what class you're even talking about. So there do exist multiple techniques for grounding LLMs. One of the more popular ones is called retrieval augmented generation, or RAG for short. What that does is, based off a user query, it embeds it as a vector, and then it searches a vector database to find the most relevant documents for that user query. And with those relevant documents, we can then pass it to the LLM as context along with the user query and receive a response that is the most accurate response since the LLM has that context. Another technique we have for grounding LLMs is called fine-tuning. So what this involves is retraining the LLM on a specific data set. For example, if we had an AI copilot for a company, we might want to retrain it on internal documents. If we had one for a specific class, we might want to train it on the syllabus for that class. Fine-tuning allows the model to memorize and recall that information, and it doesn't have to go through that lengthy retrieval process for context like retrieval augmented generation does. So although these two techniques are good, there do exist some trade-offs with both of them. For RAG, the accuracy entirely depends on the retrieval system. For example, if we have some more complex data sets with APIs, we're asking the LLM to output how we can code using those APIs. A RAG system might need to be a bit more involved. And additionally, this RAG system adds an extra step, of course, so it's going to be more processing time, more time waiting for an output. For fine-tuning, it is static, so after we train the LLM, we can't add more knowledge unless we want to retrain it. So it's not very effective for dynamic data sets. There's also a large computational cost and a lot of time to carry out training that LLM, and the data set has to be meticulously curated for the model. So there is a need for some universal, scalable, and dynamic system for grounding these LLMs, especially in the AI copilot domain. So some CMU faculty working on these systems, one is Professor Graham Newbig. A couple of his papers, he's working on grounding LLMs in cultural knowledge using Wikidata knowledge graph. He's also explored and developed a framework for a scalable and stable system for evaluating RAG systems across multiple factors. And he's also studied in what situations retrieval can benefit code generation, and has a benchmarking system for these RAG coding tasks. Another faculty member working at CMU on these grounding systems is Professor Lei Li. In one of his papers, he's introduced RARE, which is a framework that allows someone to test queries over dynamic and time-sensitive data. He's also worked on in-context learning and editing factual knowledge with that, and has come up with a method that uses demonstration context to update this factual knowledge in the LLMs without computationally expensive fine-tuning or parameter updates. And that's all I have for today. Thank you for watching.